Mm. Okay, so let me just drop a comment for people to join for just a minute. Can you hear me, please?
No, sir. We just heard you now.
Good evening.
We just heard you now. Yeah. Sir, we couldn't hear you anymore.
Sorry, I'm in a class. Call me back, please. In a class.
We can't hear you, sir, if you're already speaking. Thursday. They wanna be sweet. Hello, sir. Hello, sir. We can't hear you if you're already speaking.
It's like he's even on. He's even offline, sir. Okay.
I'm back now. Can you hear me?
Yes, we can hear you clearly, sir.
Okay. So let me share my screen. Can you see the screen?
Yes, sir.
Okay, good. So if you are the one joining us from the YouTube, you can just type your message if you have any questions. So I'm going to pick it up from there. And then for those joining us in-house, you can also write down your question. So we are live now. For anyone that wants to join, we are live. Okay, let's start. Tonight, we are going to be looking at, we have 3 objectives, but it is only one that we're going to be able to treat tonight. So I don't want to bore us too much, but I want us to at least pick something home, and then this is going to help us in modeling, and then do some other aspect of statistics and then data analysis. Excuse me, please. I just want to be sure that I'm still on. Okay, I am. Okay, so tonight we're going to be looking at what we call a Poisson regression. Poisson regression. Maybe you've heard about the Poisson regression before, or this is your first time of hearing what we call the Poisson regression. That is not an issue at all. That's not an issue. So, what did I mean by a Poisson regression? Now, maybe peradventure or in one way or the other, you've heard about what we call the mean. The mean simply means average. The mean, it simply means what? It simply means average. And then you've heard about what we call the standard deviation before. We've heard about what we call the what? What we call the standard deviation before, or you've heard about what we call the variance before. Now, anytime you have a count data, what did I mean by count data? Count data are the discrete, what are the discrete data? That is 0, 1, 2, 3, 4, 5, 6. They are called count data. And then any number, any value which is 1 point, let's say 0 0.5, 1.2, 1.3, they are called continuous data. They are called what? They are called continuous data. But anytime you are dealing with a count data, let's say for instance now, how many times a person visited hospital, or how many times a student make an attempt to write a particular exam. So they are what? They are count data. Maybe the student pick up the form like 3, 4 times or 5 times, or the patient visited the hospital like 7 or 8 times. They are what? They are count data. So immediately you check the mean of the count data, and then you check the variance of the count data, and then the mean and the variance, they are approximately equal. Please take note of that. When the mean and the variance of a count data, they are approximately equal, we normally use what we call a Poisson regression. Please take note of that. So if you want to develop a model, or you have a data set, or you are carrying out a research and you don't know which statistical model to use or which statistical method to use, the first thing that you are going to ask yourself, my data set, are they counting 1? If yes, good. Then check for the mean of that data set. The mean simply means the average. To a layman language, it means what? It means average. Immediately you check the average and then you check the variance of your data set that are count, and then the mean and the variance, they are approximately equal. They are what? They are approximately equal. Then you will opt in for what? You will opt in for a Poisson regression. You opt in for a what? A Poisson regression. So in nutshell, we normally use Poisson regression when you have a count data set. When you have a what? A count data set. Let's say, for instance, now the outbreak of disease. Let's say the outbreak of COVID-19. How many people this COVID-19 is going to affect per time? How many people this COVID-19 is going to what? Is going to affect by time? Then we use what we call a Poisson model. We use what we call a Poisson what? A Poisson model is very good when you have a count data. When you have a count data, unlike our linear model, that is maybe simple linear regression or multiple linear regression that can take account of points. So when you are talking about the continuous data set, you can use linear model like simple linear regression or multiple linear regression. But when you are talking about the count data, and we normally use a Poisson regression, and then you have to check, is my mean approximately equals to the variance? So that is just an introduction to that. So this is our learning objective tonight. Number one is, at the end of this class, you will understand the concept and application of Poisson regression. Poisson regression is very, very important, especially for those in public health, those in environmental sciences, those in agri, those in law. Law are now making use of what we call the Poisson regression. So then number two is, we are learning how to implement this Poisson regression. This one is the hands-on part of it, and then perform model diagnosis and practical interpretation. So these are the three things that we are going to be looking at under the what when we are talking about the Poisson regression model. But tonight I'm going to talk about the first one, because I have to set the foundation straight. Because at the end of the day, you can quickly put your data set in your R programming language, and then you run the data set, you have the result. How do you interpret the result? How do you choose whether to use Poisson regression model, or whether to use a negative binomial model, or whether to use another sort of model? So we're going to be looking at now. Okay. Now, what is Poisson regression? Poisson regression is a generalized linear model. Now, for those that attended our first class under what I call Practical Guide to Logistic Regression Model. Practical Guide to Logistic Regression Model, I talked about the GLM, Generalized Linear Model. GLM is like a family. Let's say, for instance, now a household. Let me call GLM household. That is, in a compound is what we call the GLM. Then how many families do we have in that compound? So GLM is like a compound. Then inside GLM, generalized linear model, we have a Poisson regression model. We have the binomial regression model, which we normally use for logistic regression. We have the negative binomial model. We have the probit model, and then we have some other model under the what? Under the family of generalized linear model. We call it GLM. So Poisson regression is a generalized linear model used to model count data. This is very, very important. Let's say, for instance, now you want to model the number of accidents that happen in a year, or you want to model the number of driver's license people renew in a year, or you want to model the number of what intervention or the vaccine or the routine immunization given to children in a year. We normally use a Poisson regression to model that, because it's a count model. Poisson regression normally used when we have a count data, where the response variable represents the number of times. How many times do you visited an hospital? How many times do you take your children to go and take immunization? How many times do you visit a particular cases or particular case in court? How many times did you appear in court this year? So if you want to model that, we normally use what? We normally use what we call the Poisson regression model. How many times a particular student, maybe you take a particular course and that student fail, how many times? So represent the number of times an event occur. The event is, let's say, for instance, for students now, if you pass a particular exam, that is an event. how many times did you write that exam? Let's say, for instance, now for the doctor, how many times did you pass through, did you carry out a surgery in a year? So those are what, those are Kant's data set. So then to have do not carry out the modeling of that Kant data set over the time, we normally use our Poisson regression model. So anytime you are hearing that, oh, I'm using Poisson regression model for this my analysis, or I'm developing a model of Poisson regression, always note that they are dealing with a Kant data of an event over time or over the interval of time. Now it's assumed that they can't follow a Poisson distribution where the mean equals to the variance. I've mentioned this. Now, in a real life situation, we may not have perfect. That is, you have mean equal perfectly to variance, but we're normally talking about the approximation. Let's say, for instance, now you've calculated your mean, which is the average. Average simply means that add all the observations together divided by the number of people that you have. So let's say, for instance, now you have your mean to be 5. And then you now test it, you now discover that your variance is around 4.9. You can approximate this variance to be equal to 5. So by approximation now, mean is equal to what? Is equal to the variance by approximation. Mean is equal to what? Is equal to the variance. So in that case, we normally use Poisson regression model, which is we normally use it for Kant model. Kant what? Kant model. Example across all fields. So example, now let's start from the medicine. If you are a doctor here or medical lab scientist, so we can look at this from the angle of medicine and public health. Let's say, for instance, now modeling the number of hospital visits per patient in 1 year based on their age, their gender, and then the comorbidities. Comorbidities simply means that you are checking the two diseases. Are they affecting each other, or you are looking at more than the relationship between two diseases together. Now, if you want to check how many times a particular person visited a clinic to check for a status of about diabetes, we normally use a Kant model. Then you can have a research question. Does age increase the expected number of hospital visits for diabetic patients? That is, does the age influence the number of times a particular person that has been diagnosed with diabetes visits the hospital? So you may want to check that. Then you use what we call a Poisson regression. In education, you may want to predict the number of absence a student has in a semester based on the family income, parental education, and school location. Let's say, for instance, now, those coming from the rural area to come and learn in urban, you may want to check how many times did they come to class? How many times did they attend or absent from class? Or let's say, for instance, now if you have an health center in urban area and the people from rural, how many times did they visit the hospital? You may want to check what are the attributes that contribute to them not coming to the hospital. Is it the location of the place? Is it the distance? Is it the income? And so other things like that. You may want to check that, so that based on that you cannot recommend that to a policy maker or the government that they want to use it to make a decision. So you can use the Poisson regression model to carry out that particular aspect. Now look at this research question. Are students from rural area absent more than students from urban? You may want to check those students coming from rural area, or those mother coming bringing their children for an immunization exercise in urban area. Did they have the same as the absent number compared to those that are staying in urban area? So you may want to compare that. Then we also use what we call a Poisson regression model. The third example is in agriculture. Let's say those people that are into agric. You may want to check. You may want to model the number of pets per plant based on the fertilizer type. Let's say, for instance, now you've discovered that if you plant a particular maize, or you plant cassava, or you plant cocoyam, you discover that you have a lot of pests. Let's say you have thousands of pests. They normally attack that particular crop. Now you now have this type of fertilizer, or you have a insecticide or any other things that you may want to use to reduce the pest. You now want to check, does the application of organic fertilizer reduce pests in your farm? You want to model that. You want to model the number of pets in a particular in a particular farm or affecting a particular crop. So you may use the Poisson regression model to model that. By the time you use Poisson regression model, you will see how effective the fertilizer that you've applied, or you use the normal organic fertilizer or the potassium, nitrogen fertilizer, NPK fertilizer, or your other type of fertilizer for your crop growing. So you will know whether they are effective or not, whether they are statistically significant or they are not statistically significant. So you can check that using a Poisson regression model. Then in law and criminology, for those that studied law, for lawyer in our midst now, lawyer are now going into data science and data analysis now. So for the law and those that study criminology, you may want to analyze the number of crimes per neighborhood per month based on the unemployment rate, police patrol frequency, and poverty index. You may want to check, let me check the crime of, let's say, stealing over the year. How many cases of stealing recorded by the police over the year? Then checking some attributes, let's check the unemployment rate. Is unemployment rate significant? You know, when they are interrogating those criminals, they will have to say, ask some question from them. Where last did you work? Do you have a job? Do you have this? Do you have that? And some other things. What do you do for a living? And some other things like that. So you may want to check, is there any is unemployment contributing, or is it a factor contributing to this particular crime? Let's say rape, or is indecent dressing contributing to the act of rape and some other things like that, so that by the time you are recommending this for government will know, or the policy maker will know where to tackle the situation. It is the unemployment that is highly significant to the crime of stealing. It is indecent dressing that is highly significant to the rape or the murder or some other criminal offenses. So you may want to check that. So by the time you have such data set, then you can use a Poisson regression model to do that. Thus, look at the research question that you may want to carry out under this. Does an increase in police patrol reduce the number of crime? That is, because we have more patrol in this community, we have vigilante patrol, we have the state police, we have the national police. That is why those criminals, they cannot perpetrate their work. So we want to check whether those areas that are not that they don't have the police patrol and some other thing, whether the number of criminal cases has increased in that area. So criminologists, those that study criminologists, they normally use that part, which is very, very crucial and essential for the law enforcement agency. Now, for those in business and finance, you may want to predict the number of insurance claims filed per customer based on the age, driving history, and some other location like that. So you can also apply a Poisson regression. In nutshell, what I'm trying to bring out here is that there is no field that you are coming from. There is no field, there is no background that you are coming from that you don't need the Poisson. So provided that you are making use of the data set, you are making use of what? You are making use of the data sets. And then once you discover that your data set is scant, and then you check some attribute, does the mean and then the variance, are they approximately equal? Once they are approximately equal, then you can use what we call a Poisson regression model. A Poisson regression model. And also, for those people in the public health, you may want to check the outbreak of a rare disease, the disease that is not common, that can affect millions of people at an interval. Then we also use a Poisson regression to model that. Now, key assumption for using Poisson regression model. What are the assumptions that you have to check for? And let me say this expressly, that in statistics and in data science, any model that you are building they are built on the assumption. They are built on the assumption. So when you put all this data inside your system, those are the things that they've inputted at the back end of the system. So, but the assumption here is that you will be the one that you are going to check the assumption yourself. Because if you put anything, like I say, that garbage in, garbage out, if you put wrong thing inside the system will also give you wrong thing back. So it is not left for you with the understanding of the basis of the what of this particular model called Poisson regression model, and then the assumptions that follows. The assumption that follow, and then the number one assumption is that, remember I told us that the mean and the variance, they are key two things that we normally check when we are talking about the Poisson regression. They are what? They are two things that we normally check. Is my mean approximately equal to the variance? Is my mean approximately equal to the variance? Then another thing that we're going to check is that the observation are independent. Independent simply means that the sample, the sample of Mr. A does not have anything in relation to the sample of Mr. B. The crime committed by Mr. A, they are not familiar, they are not of the same family with Mr. B. So the data sets are not what? They are not dependent. So that means that they are independent. Then the third assumption that we normally check before you can use Poisson regression model is that events occur randomly and independent over time. Over time is very, very important. Over time, you have to check the event over time. You have to check it over time. You can't just use just one let's say for instance now you are just checking it for just a month. Let's say you are carrying out the experiment for just a month. You can't just use just single days to make your what's it called, your analysis. So but it has to be spanked over a month so that you can get a good outcome, so that you can have a outcome that is robust. We normally use robust statistics to get the results that are more precise, that people can hold on to. Now, this is just the mathematical representative. This is the regression model. If you look at this, my right hand, which you have beta naught, the same as that of what's that, but the only thing that is different is the left hand side there, that we have log lambda subscript I. Remember, the parameter of Poisson is lambda. The parameters of Poisson is lambda. So why the lambda subscript I is called the expected count. That is how many times did they commit this crime? How many pests did I have on my farm? How many people does this outbreak of disease affected? How many people visited this hospital? How many times a particular student take an exam? So that is the X. Then that is the lambda subscript I. And then we have the X's. X's are the independent variable. Those factors that contribute to the outcome. Maybe there is no the rate of unemployment. Unemployment is one factor. The indecent destiny is another factor, and some other things like that. Why the beta that you are seeing here are called the coefficient of the independent variable. In machine learning or data science, we normally call this beta weight. We call them weight of each of the independent variable, weight of each of the independent variable. Now, when to use Poisson regression? You may ask, okay, you have been saying this, you have been saying this. When can we use this model? When can we use this model? Number one, when the dependent variable is a count. I've mentioned this. You have to establish the fact that your dependent variable is a count number, and not when we have continuous variable. Immediately you have dependent variable to be continuous, that means that you cannot use a Poisson regression again. And then you are going to be using what we call your simple linear regression, or you use multiple linear regression. And I've explained what I mean by the continuous. That is, you have decimal. Let's say we have 1.5, like your weight, like your height. If they are dependent variable, you can't use Poisson. Poisson, before you can use Poisson, your dependent variable must be count. Must be what? Must be count number. Now, another thing is when the data represents event per unit of time. That is, you want to check it over the time period. That is, over the span of a time. Then you use Poisson regression. Then, when counts are non-negative, that's another thing. Your count must not be negative. Must not be negative. You can have 0. Yes. What if the crime did not occur in this particular month that I've observed? So that means I have 0. What if there is no accident in this particular week? That means I have 0. What if nobody visited the hospital in this particular month? So that means I have 0. But it must not be negative. It must not be what? It must not be negative. Non-negative and not over dispersed. Over dispersed simply means that when your variance is greater than your mean. Immediately your variance is greater than your mean, you can't use Poisson regression. There is another model called a negative binomial. A negative binomial, we normally use it when your variance is greater than the mean. So we are going to be talking about maybe in our subsequent lectures. Let's say our subsequent lecture, I'm still going to bring that on up to come and take us here. How do you use negative binomial to formulate a model? What are the conditions? Because in a real life situation, a lot of conditions, you'll be seeing a lot of events. So how do you now know the right model to use to model a particular event? So when you are interested in the rate modeling, we normally use this in rate modeling for those in demography, for the demographer, then for those in medical demography, sociology, social sciences, they are particularly on what the cases, what is the cases per population for those taking prevalence. You may want to check what is the prevalence of malaria in this particular community. So we normally use it when you have case per thousand population. So we can also use a regression model to take care of that. You may ask, how is it different from the linear and logistic regression? Remember, in this class, we've talked about the logistic regression before. So linear regression models continuous outcome. I've mentioned this. When your outcome, another name for outcome is what we call dependent variable. And then another name for outcome again is what we call the response variable. So when you have your response variable or your dependent variable to, or your outcome variable to be continuous, you can't use a Poisson regression model. Then you will use what we call the linear regression model. I've mentioned that. Then logistic regression models, when your outcome has just two binary outcome, is either the disease is present or absent, is either the person pass or fail, is either the what's it called, is either you get employed or not, is either the person pay back the loan or not, is either your crop survived or not. So we normally use logistic regression to model that. So we don't use Poisson regression. So Poisson regression model is model scant number of events. Please take note of that. If you have something to take home tonight, please take this home, that we normally use Poisson regression when you have a can't event. Can't event. Assume a Poisson distribution and use a log length function. The identity of Poisson regression when in the family of
Um, I think you are breaking, sir. Sir, can anyone hear me, please?
Yes, I can hear you,
Yes,
sir.
I
It's
can hear
like the
you.
network is.
Okay. I think it is network, so he will be back in a moment. Okay, for our YouTube viewers, it's just a late network glitch. I believe he should be back in a moment as soon as he's back. So he has left so as to join back so he can have a better network from his end. So, you know, thanks for the patience. So as it's trying to fix the network, so if there's any question that we have, we might be writing them down. So I don't know, you will be able to attend to it before the close of the lecture for the day. So if there's any question that you'd like to ask, or if there is any clarification you need in the aspect of Poisson regression, linear regression, or logistics regression, although logistics regression and linear regression are one of the topics that have been touched in the past. We've been able to look into linear regression, the criteria for using linear regression, then logistic regression. So today, that's why we are focusing on Poisson regression today. So if there's any clarification you need for our YouTube viewers, so you could just state it down. You could note them down. So so it can be attended to possibly during the time of the question and answer. So that you can have a clear understanding of what he's talking about. Actually, if I should add to what he's been trying to talk about, in data science, what data scientists do is that we build models. And data analysis is just a subset of data science. And in data science, it's more of a applying your mathematical skill, be it algebra, be it statistics. So these are the things that we'll be applying in building our model. So part of the things that should be considered while building models is depending on the kind of model you want to build, is our regression. So, and there are different kind of it. That's the linear regression, logistic regression, and Poisson regression we are talking about today. So I believe when he's back, he would shed more light into that. And so if I should also talk about our upcoming program that is coming, that will start by September 12th. It will officially start by September 12th. That's when we'll be talking, detailing about data analysis. So we'll be covering the descriptive data analysis and the differential part of it. And we'll be touching you'll be taught how to use tools like Excel. We'll be taught how to use Python, R, then SPSS, in order to deal with some in order to make conclusion through data, and to make reasonable conclusion. So that's our program will be to be starting on September 12th, majorly, and we'll be starting with Excel. So through the course of the program, we'll be discussing quite a lot of things. Maybe touching how we can use Excel to make charts. That's the distributed statistics part of it. Then how to use data to make inferences, and that's the inferential part of the statistics. So it's going to be an interesting one, and these are third sets we'll be having. Okay, so that's it about that. So I believe you'll be back soon to shed more light about the program, the upcoming program. Okay, so we can stay tuned till he arrives. Thank you very much for your patience once again. Okay, thank you very much for the patience once again. We've put a call through to him, so he will soon be back. I think it's a network glitch. I think it's a network glitch. So, but he will soon be back with us. Thank you very much once again. Hello, please. Am I audible, please? Please confirm if you can hear me.
Yes.
I can hear you.
Okay, thank you very much. So, for the benefit of those who are on YouTube, those who are joining us on YouTube, I'll like to do a quick recap of what will be taught in our next cohort. So from the first week. So it's going to be a loaded one. So from the first week, we'll be starting with, just like I said earlier, it will be starting on the 12th officially. We'll be starting officially on the 12th of September, which is next month. That's which is on a Friday of next month. However, before that, that will be a preparatory class just to prepare us ahead, before
Hello, can you still hear me? Hello? Hello, class, can you read me?
Yes, sir. You're audible now.
Ah, sorry, please. I don't know. I have like three networks here. No problem. Thank you so much. Let me share my screen back, and therefore our people on YouTube. So thank you for staying. I would really appreciate. Let me quickly share my screen, and then let's round it off. So lastly, we we're going to be looking at the practical parts in our data camp. Our data camp, which I've explained. Sorry. So in this our data camp, we're going to be checking the practical part of it. So it's going to be for 7 weeks, and then starting September 12th. So it's starting September 12th. So if you have interest, you can join us. So lastly, before we stop streaming, let me also show you what we have for that camp. For those that would love to join, this is what we're going to be covering. Now, we're going to be having uh, pre-camp. Pre-camp is going to start next month 11. So where I'm going to be taking variable classification, variable selection. How do you classify your variables? How do you identify each variables in your data set? Then how do you select your variable selection? And how do you design a good questionnaire design? A good questionnaire. How do you design that? So that is going to be for pre-camp. So I'm going to be taking that. Then the week 1 is starting September 12th. So in week 1, day 1, we're going to be covering introduction to statistical analysis using Excel. Then how do you write a simple function in Excel, a descriptive statistic graphically? Then we're going to be checking descriptive statistics for quantitative and qualitative, then testing of hypothesis using t-test and correlation. Then all these, we're going to be having a 30-minute for the theoretical part, where we're going to be using 1 hour 30 minutes or 1 hour 20 minutes for the hands-on, that is practical part. You are going to be using those software. Then the same thing go for the SPSS. Those are the things we're going to be covering in SPSS. Excuse me. The same thing with hands-on. And then for the R class, these are the things that we're going to be also looking at in R class. Then if you look at my R for week 5, day 2, week 5, day 2, I'm going to be talking about the Poisson regression model. Here, we're going to be dealing with the practical part of it, which is our objective 2 and objective 3. Then we're going to be working with the real life data set. Then we're still going to look at zero inflated binomial model. Then we're going to look at the exponential model using R. And then for Python, those are the things that we're going to be covering in Python for the 7 weeks of the lecture. So if you are interested, you can join us for that. So by sending us a message, and we're going to tell you the procedure that you are going to follow. So please subscribe to our YouTube channel, so that when we have subsequent classes that are free and educative like this, you are going to be getting the notification, and then we're going to be linking you up with that. So let me welcome 2-3 questions from our people from YouTube. So if you have questions, you can drop it, then I will read it and then address the the situation. So you can write the question down, and then I'm going to address that. So if you have any question for me, so let me look at our group chat. For the last time before we call it a night. So in the absence of no question, and then I'm going to stop streaming, and then I'm going to be sharing the link to our various groups so that we can look at it again. Then if you have any question for me, you can reach out to me. So thank you so much for joining to. So let me stop streaming now so that we can come back to in-apps.